Talking about graphing tangent functions now. We've graphed sine and cosine functions. We've moved them around. Just like with sine and cosine, we'll think about this angle theta. We'll think about how this angle theta moves and how that changes what the tangent value is. It's important to remember that tangent is sine over cosine, which really means it's the y value over the x value. Well, at 0 degrees, the y value, the height is 0. The graph hasn't moved up or down at all. Your height is 0. But your distance across, your x value, is 1. So the tangent of 0 degrees is y over x, 0 over 1, which is 0. As this angle increases, as theta starts to change, that's interesting. As theta starts to change, you two, go away. The x values get shorter. The x value was here, but now it's here. And it's going to keep moving back and moving back and moving back as this angle increases. So the x values are getting smaller, but the y values are getting higher. The height starts increasing, increasing, increasing as the angle moves over. So you'll see this dynamic where it moves from 1 and it increases rather quickly. In fact, if you think about this angle moving from here at 0, at 45 degrees, once you hit 45 degrees, the sine value and the cosine value are the same, which means the tangent of 45 is something divided by itself, or it's 1. Now we keep moving. The cosine values are getting smaller, the sine values are getting higher, and right here, just before we get to 90 degrees, let's think about doing like the tangent of 89.9 degrees. Well, the cosine value on bottom is really, really small. Let's say it's 0.0001. And the sine value on top is pretty big. I mean, it's getting really, really close to 1. And so we have a fairly large number divided by a fairly small number, at least relatively speaking. I know 0.99 isn't actually a large number, but compared to 0.001 it is. But if I do 0.9999 divided by 0.0001, we get 9,999. It's actually an incredibly large number that can keep growing bigger and bigger and bigger with the more 9s and 0s we tack on before and after. So it actually approaches infinity. In fact, it goes to infinity all the way up until you hit 90 degrees. And at exactly 90 degrees, the tangent of 90, well, the cosine value is 0, the sine value is 1, and 1 over 0 is undefined. So you have an asymptote, and we'll talk about that in a second. But the tangent of 90 is undefined. If you try it in your calculator, it'll give you an error. I'm going to make sure which mode I'm in. I'm in degrees, so I do the tangent of 90. And it says, domain error, it's undefined. Let's think about going the other direction. From 0 degrees, as I go downwards, things are now negative. The cosine value is positive. This has a high cosine value, but a negative sine value. So tangent's going to be negative in all of these spaces, but it keeps on going from 0, here it hits 1, and now it's getting really, really close to infinity, really close to negative infinity. Here it was negative 1, negative infinity, until here it's undefined again. So tangent has a period of 180 instead of 360. The period of tangent functions is 180. Because it's really going from negative 90 degrees up to 90 degrees, and then it hits the absolute, or the asymptote, undefined, then does it again, asymptote undefined, and it just keeps going around and around and around, but every 180 degrees it cycles back onto itself. So the period of a tangent function is 180 degrees. And you can graph them just like how you graph sine and cosine in a lot of ways, and they look very different, as you'll see. But I'm going to think about going 1, 2, 3, 4, 5 hashes. I still do 5 hashes, but now I do 2 to the left and 2 to the right. And if the period is 180, my scale is going to be 180 over 4, which is 45 degrees. I'm going to count by 45 degrees. So here's 0, here's 45, here's 90, here's negative 45, and here's negative 90. And we know that at the tangent of 90, it's undefined. Because 90 degrees right over here is when you're doing sine over cosine 1 over 0, and that's undefined. And the tangent of negative 90 is also undefined. Because here, it's 0 over negative 1, and that's also undefined, but everything in between has some value. The important ones to remember are that at 45 degrees, the tangent was 1 because it was something divided by itself. That was kind of weird. Something divided by itself. So the tangent of 45 is 1. And the tangent of negative 45 is negative 1. Excuse me for a moment. I need to stop saying excuse me for a moment because I'm only actually gone for a split second in your mind, but that was like 12 seconds that I was dealing with something. Anyways, we have points at negative 1, 1, and also 0. Remember the tangent of 0 right here was 0 because it's sine over cosine, 0 over 1, and 0 over 1 is not undefined, it's 0. And tangent goes from negative infinity through these points and up to positive infinity. Then it repeats this pattern over and over. So I go 1, 2, 3, 4 more points. Here's yet another asymptote. I'll have negative 1, 0, 1, and I draw this curve again. Going in the opposite direction, I have 1, 2, 3, 4 points. Points at 1, 0, negative 1. There was an asymptote here. And it just keeps on repeating this graph over and over. In fact, on my calculator, I can graph the tangent of x. Y equals the tangent of x. My mode is in degrees. My window will go from, what is this, 90, 180, 270, from negative 270 to 270. And I'll count by 45s. And my y's will just be my y's. And there are your 3 asymptotes. The calculator kind of has to draw these asymptotes because it doesn't really know what else to do with that information. So those lines right there aren't actually part of the graph. The calculator is just kind of trying to show you where the vertical asymptotes are. And that's your tangent function. It has a period of 180. It doesn't really have an amplitude because it's not a wave, but we kind of give it an amplitude name. So here, my period is still going to change by the value b. The formula, which I haven't really written down anywhere, just looks like this, a tan b theta, where a kind of stands for the amplitude, but not really. I'll explain what I mean by that later. And then 180 over b is how you calculate your period. So right now, if I'm going to do this in radians, I would also do pi over b, pi if I'm in radians, so pi over b is my period now. Since my b value is 2, the period of this is pi over 2. And I'm still going to go out 4 hashes, 1, 2, 3, 4. I just go 1 in each direction. I think I'll jump to one screen now, 1 in each direction. And so I know here I have an asymptote, and here I have an asymptote, and I can go 1, 2, 3, 4, and put another asymptote. So there'll be another asymptote over here. But I'm just going to deal with this middle section first, right down here. My scale is going to be my period times or divided by 4. So whenever you're going to find the scale of your graph, take your period and divide it by 4. So it's pi over 8. So I'm going to count by pi over 8s on this graph. So here's 0, here's 1 pi over 8, here's 2 pi over 8, which is really pi over 4. So it should be 3 pi over 8, it should be 4 pi over 8, which is pi over 2, 5 pi over 8, and 6 pi over 8. In the other direction, here's a negative pi over 8, a negative 2 pi over 8, and then you get the idea. The tangent at 0 is 0. The tangent at pi over 8, well, since my amplitude here is 1, my a value is 1, I'm just going to go up to 1 here, and down to negative 1 over here, and my graph looks like this. So here I start at the point 0, I go up to 1 here, down to 1 here, and my graph goes like that. So I start at 0 in the middle, 0 is in the middle, up 1 on the right, down 1 on the left, and the graph has this curve. That's tangent of 2 theta. All that happened was the period on the previous function, which looked like this, the period on this function got cut in half. It was at 90 degrees, which is really pi over 2. That's where the asymptote was, at 90 and negative 90. But now it's at 45 degrees, which is really pi over 4. We'll do 2 more examples. Here's 2 tangent of 3x. I will do this in degrees. Right now my A value is 2, that's my amplitude, and my B value is 3. So the period, since I'm doing this in degrees, is 180 over 3, which is 60. If I divide that by 4, my scale is going to be 15s. I'm going to count by 15s. So 15, 30, then 45, 60, 75, 90. So negative 15, negative 30, negative 45, negative 60. I think I jumped too far there. That. And it's always going to be 2 to the left and 2 to the right for your asymptotes. So 1 here, 1 here. Well, here's how this A value changes things. Instead of going up and down 1, I'm going to go up and down 2 from the middle. So my middle point is still 0, 0. The tangent of 0 is 0. But now the tangent of this 15, when I plug in 15, it becomes a 45. 3 times 15 becomes a 45, and the tangent of 45 is 1. That means that 2 times the tangent of 45 is 2. This is going to be at the value 2. If I call that 2, 1, 0, 0, negative 1, negative 2. And so at negative 45, well, I'm plugging in negative 15. At negative 15 degrees, the value becomes negative 2. And the graph is just more elongated. So I have negative 2, 0, positive 2. And this graph looks like this. And 0, positive 2, negative 2. This graph looks like this. All that happens is, I call it the middle point. This point that's halfway between your asymptote and your center gets moved up to whatever that A value is. And you can do all these things by calculating, by plugging numbers into tables. I mean, once you have your scale of 15, you could go 0, 15, 30, 45, 60. You can plug all these in and kind of generate your pattern that way if you wanted to. I think it's better to get the idea of how these things space themselves out. So here's our last one. We'll do the same exact thing, 2 tan 3x and 2 tan 3x, but I'm going to move this to the right 15 and down 1. Other than that, everything stays the same. So, what's my scale? Just like on the last problem, my scale is going to be 15s. The period is 180 over b, which is 180 over 3, which is 60. So for my scale, I divide that by 4. So I'm counting by 15s. There's 15, 30, 45, 60. But now what I do is I think about moving this thing to the right 15 units, which is here. So if that's 15 units, the center of my graph is going to be here and here, because everything was moved right 15 and down 1. So now everything is centered around this middle orange point. So really from this point here, I want to go right 4 hashes. 1, 2, right 2 and left 2. So there's right 1, 2, and there's left 1, 2. These right here are now my asymptotes, because everything was shifted, phase shifted to the right 15. So that orange stuff in the middle is almost going to get confusing at this point. I'll probably hide it in a second. But everything is the same now. At the middle, I'm at 0. I'm going to go up 2 and right 1 hash. So there's up 1, up 2, and right 1 hash. And there's down 1, down 2, left 1 hash. So I'm at negative 3 now. And the graph looks like that. I think I'll erase everything else that's kind of in here, blocking things. And that pattern keeps on repeating. So 1, 2, 3, 4. Out here would be another asymptote. And I have a center here, and down to and over, and up to and over. And this graph would go like this. And 1, 2, 3, 4, there's an asymptote here. My center is here. Down to left 1, up to right 1, And there's that. You can see how this graph and the other graph are basically the same, only it's like each little piece here was taken and moved down and to the right a little bit. But other than that, they're all the same. There's some tangent for you. I think that covers everything. Wonderful.